Hi, everyone. Really hope you're all enjoying this incredible evening event and massive support for ADDY, for ADDY's family, and for all the incredible work in cancer research that's going on that they're supporting and that you're supporting. I'm really sorry that I'm not able to be there. I'm actually, as you see this, on my way to a cancer research conference in Japan. I think the first time that I've missed the event, but hope that these words give you a little bit of sense of what all that you are doing is helping going forward in the field of pediatric cancer and in the subspecialty or subfield of sarcomas in particular. I'd also like to really shout out a big thanks to Jessica and Dave and the entire Hill family, friends, and everybody who's here. Jessica asked if I would just kind of update a little bit on what the funds have been used for in the last couple of years and where we're heading going forward. So we do have exciting work going on, as always, an incredible team of researchers, both in my lab as well as with my collaborators around sick kids, around the Toronto cancer research community, and around the world. Actually, we have a number of international collaborations as far away as Australia, England, Sweden, and many other countries in Europe, as well as Japan. So I thought I'd just maybe highlight three major areas, if you will, that we are particularly intrigued about. One of these I've touched on very briefly last year for those of you who were here, which is now we, along with many other people, are working along this concept of could we actually prevent cancer, or could we intercept it when it's at its earliest stages? And it's sort of based on the same principle of infectious diseases like measles or mumps or chickenpox, where over many years vaccines have been developed that are used to prevent the disease, or at least to minimize how serious they can be. And so using technologies that we're developing in our lab, as well as with collaborators in Toronto, as well as in several centers in the US. We started working on this with some of the funds in the first year from Team ADDY to see, are there sort of targets, if you will, on cancer cells that develop in children that we could essentially target with a vaccine? Could we design a vaccine that recognizes these abnormal proteins, these abnormal things expressed on the cancer cells, and use the vaccine to kind of hone in and, if not kill those cells, kind of teach our immune system, or teach the child's immune system to destroy them. And we started this with funds from Team ADDY to get some preliminary data. And I'm very happy to tell you that with that preliminary data, as well as some other data generated from colleagues, we submitted an application to the Alex's Lemonade Stand Fund, which is a similar fund actually in the US, generated from a family, from a child with a cancer some 20 years ago now. And the Alex's Lemonade Stand Fund grant that we received is very substantial. It's actually about $5 million US, and that has completely changed our entirely lab focus to really start seriously going after a vaccine targeted against certain kinds of childhood cancers and those who are predisposed to cancer. So it was with the early use of the funds from everything that you've supported in the last couple of years that allowed us to be able to really make this happen. And one of the things that I've said in the past and continue to say is the Team ADDY funds really allow us to explore somewhat crazy off-the-wall ideas that traditional funding agencies just don't really allow for. And so without this, we would never have been in a position to be able to really blow this question up and go after it in a big way. So we'll see over the next 2 to 3 years, we're going to be generating a lot of data with the hope that eventually have this idea of a vaccine into clinical trials. A second area, which is quite exciting, and I mentioned, I think, one of the first times I spoke, was we use various models of childhood cancer to understand the biology and the genetics of it. And we also use these models to test different drugs to see if there are drugs that can be used that kill cancer cells that we might be missing, if you will, the drugs that we might be missing. And one of the ways to do this, we have a collaboration with colleagues in Ottawa as well as in Australia, where we used zebrafish. These are these tiny little tropical fish that are transparent, and one can actually basically create these fish that have the cancer that a particular child has. You can actually take the sample of the tumor from the child, stick it into the fish, they grow in the fish, and then you can expose those fish to hundreds, if not thousands, of different drugs and see what drug or what drugs specifically kill the tumors in a particular fish. And then we can then translate that by using those drugs in that particular child. So this is a very precise approach. We call it precision oncology, precision medicine, because it's not assuming that every child will respond the same way. And so working with our colleagues, we have just recently published the first paper using this technology in about 10 individual children's tumors, and we're able to show that within about 3 weeks, we were able to actually identify targets in the fish that could then be drugged, and then ultimately translate that drug or provide that information to clinicians who can then explore using that drug in their particular patient. So this is a new area that we're venturing into for us, again, being able to help to be generated from Team ADDY funds and using it in collaboration with others who have great expertise in the use of zebrafish. So this idea of precision targeted therapy is very, very exciting. And then the third area that we are really excited about is some people or some children who are genetically predisposed to cancer never actually develop it. So they have a genetic alteration that would suggest they should be getting cancer or as an older child or as an adolescent or an adult, but they never actually do. And with that information in mind, we actually now know this concept of resilience. Why is it that some people do not develop the disease we would predict them to develop? And so we're now working with a large group, an international group, to really explore this question, because if we know what it is that's protecting these individuals from developing cancer, well, then we should be able to use that information in individuals who are at risk to then kind of interrupt or prevent the cancer from actually happening. So these are exciting areas that we're heading towards in the field of childhood cancer research, supported entirely through ADDY's fund, and we are absolutely thrilled to do that. The last thing I'll say before letting you get back to the excitement of the party and the music and everything else that's going on is now is a very troubling and challenging time for us, because much of the research that we do and all of our colleagues across Canada is very dependent on funding from the U.S. federal agencies, the National Institutes of Health. And recently, over the last few months, this funding has been cut off to internationally, so countries like Canada are no longer going to be receiving this funding, and so we really need to think and use wisely our own resources to ensure that we continue to lead going forward. So I'm going to leave it there, but I also want to leave by this note that every day in my office where I'm sitting now, there is the Team ADDY sticker on my lab wall, which is it is dedicated to Team ADDY, and the entire team of colleagues in the lab, and especially on the clinical side of the ward, remember her so much every day. And it's with that memory that we are able to keep on recognizing we have a big job to do. ADDY would expect us to do this so that someday, hopefully not too long, cancer in children is no longer something that we talk about. So thank you, ADDY. Thank you, and have a great evening. Bye-bye.